ready to start tear down of this 2.6 workstock 6.7 Cummins engine. This is one that we built 2 years ago, or 2 Poland seasons ago. Very successful truck, engine, everything, as far as we knew, held together good, but the truck changed hands and the new owner wanted to, go through and check everything, see where the engine was at, see if we needed to freshen it up or what was going on with it. So we did a leak down test, pulled the injectors, did a leak down test, and found we had a couple valves that weren't sealing, which is, to be expected, but also had a little pressure in the crankcase too. So we pulled the head, found we had a piston that was just starting to come apart, starting to melt. So we tore into this thing. We found the cylinder head was cracked pretty bad. Every cylinder was cracked, and we got to investigating the telltales or tattletales, heat tabs that we put on. They were all popped, and so obviously this engine had gotten hot. Maybe the water pump didn't get turned on one run, or the fans malfunctioned, but regardless, the engine had gotten hot, 260 plus. So cracked the head. So it was time to go through this thing. Like I said, it had a hurt piston, and it was time to go through it. So now we are basically reverse engineering this engine, mocked it back up, have a different cylinder head. I took this head and I measured valve recession, so the valve face depth. Checked my cam timing, verified it's where it was, which I was very happy that it was exactly within a half a degree, actually dead on for where I had it when I assembled it. So we know that no keyway slipped or we didn't have any issues there, and we know it's accurate. So our cam time is verified, different cylinder head, but we documented the valve face depth, and we mocked this thing back up to check our valve to piston clearance. This engine was pretty unique. It was a custom build for this application, and it worked very well. We were happy with the power and performance, so we want to make sure it would go back together the same way. Might make a few changes, try to even improve it even more. So again, here we are, mocked up. I checked my valve to piston clearance, intake and exhaust, and now we're going to tear this thing down, check it out. This engine had 54 dyno pulls. 2 of them were just getting it broke in, cam broke in, and then 2 soft hits, did a retorque, and then we had 52 dyno pulls between about 1,040 was probably the lowest, and 1,275 was the highest. Most of them were around 1,080 to 1,100. And then we pulled the oil pan, and when we got back, we pulled number 6 rod cap off. Bearing looked great. That was in, I think, Engine Builder magazine and Diesel World magazine, where we did an article on that, and put it back together, and roughly, I'd say 27 to 32 pulls going down the pulling track around that 1,100 horse range. A couple times it had a bigger turbo and open classes, but for the most part it was in the 1,100 horse range. So 90, 85 to 95, loaded pulls on this engine. Another thing, we took an oil sample when the new owner bought this truck. Before we did the leak down test, we took an oil sample, sent it off, and about the time that we found the upper end wear and damage to the engine, we got the results back that there was coolant in the oil, and that's when we pressure tested the head, found all the cracks. So water in the oil, a lot of passes on this engine. Simpico Super Racing oil the entire time. Not the best maintenance. I will not hide that. Very poor maintenance for what it was. Or should I maybe say poor maintenance, but not the best maintenance. This oil was probably changed 3 to 4 times during that entire span. So for Simpico oil, hopefully everything looks good. We're going to knock this thing apart and we're going to check it out. Coolant in the oil, poor maintenance, lots of passes, high power. We're going to tear this thing down and show you everything. Good, the bad, the ugly, whatever it is. So stay tuned. Pretty much what you would expect for having the oil analysis with water or coolant in the oil. Lots of sludge, but just thick black sludge. I don't see any metal, so it's a good sign. Definitely it's what I would expect, but I don't see one piece of shiny metal, so that's killer. So if you follow our videos regularly, especially our engine videos, you'll remember we did a video a while back where we tore down several engines after dynoing, and we checked the torque with a beans girdle like this engine has, and we had lost torque. We lost 20 to 30 foot-pounds of torque after running. Now this engine has about 3 times as many passes on it, if not 4, than those particular engines had. Now this girdle is about a year older than those, but very important, we want to check that. So we're going to go ahead and on teardown right now, we're going to go back and see, do we still have 125 foot-pounds of torque on our main studs? If not, what do we have? All right. Yeah, I'd say that one was still pretty well dead on. Yeah. Let's jump over here. Now that one moved a little bit. It's right in the center of the block. Again, probably 5 foot-pounds of torque. And that's journal number 4 right in the center. This here's number 5. I'd say that moved about the same amount. Let's check here. Number 6. Yeah, if it moved, it was barely. Now this one moved a pretty good amount. So number 6, this one had backed off. That was about the same amount. So very little, but we do have a little bit of torque loss. So once we get this all the way apart, we'll go back into this some more and show you what we actually found the cause to be. So not bad, and we'll see what the main bearings show. You know, before I bust this other number 6 rod down, let's throw the torque wrench on the rod bolts. These are Wagler Street Fighters, ARP rod bolts. See if they're still at 130. Yep. Yep. So that's a good sign. Wagler Street Fighters, ARP rod bolts, still at full torque. So I definitely like seeing that. make some room for these rods and pistons, and let's knock them out. Caps are still doweled nice and tight, so that's a plus. All right, number 6 rod bearing, as seen on TV. Now this is the cap side. Check that out. Virtually no wear. Again, that's the cap side. So this is number 1 cap side, but if you get in close, right here, that little squiggly line, that's a shaky hand when we're measuring bearing clearance. So coming in here with a dial bore gauge that has machine ball ends, rocking to find our accurate measurement to properly measure bearing clearance, and you still see that. That's not a scratch, that's polish. It's micro polish from that machine ball. So that's unbelievable. So I can't wait to get these things out. Moment of truth, number 6. Would you look at that? Now, I cannot see. No, I can. I can still see the squiggly lines there where we check bearing clearance. So there is, I mean, the slightest amount of wear. The coating is still on this H series Cleveite bearing. So I can't wait to measure these up and see where they're at, but tickled pink. And this is number 6. Number 6 always takes a beating because number 6 is the furthest away from the oil pump. So it's the last in line. So on an extended downtime, cold start, it's going to have a lack of lubrication. If you do get any air in the oil, or if you have a loss of oil, momentarily number 6 is always the one that's going to get starved. So when number 6 looks that good, that is awesome. I can't wait to get this thing the rest of the way apart. Also here, let's take a look now too at piston skirts. We coated these with Teflon. So Teflon skirt coating, this is number 6. Your problematic cylinder on a Cummins, and it's still got all the coating all the way around. One little line right there, one little scuff, but overall That skirt just looks awesome. Crank pin looks great. Number 6 main bearing. This is our cap. So this is the load side. See, no signs of edge loading. Very minimal visible wear. See a little, load right here, as you'd expect at that power level. But bearing still looks great. All right, here's number 7. Looks about the same, maybe a little more visible load right here, but again, I don't see any edge loading per se, which shows that the crank is deforming and twisting and egging under load. I don't see any edge loading. Okay, here's number 4. We do see, it looks like this bearing was taking a beating. And this is, again, this is number 4. So this is the center of that crankshaft. Not horrible. Let's try to let that focus. It's hard to catch this sometimes, but not terrible. But that bearing was taking a beating. I can barely, ever so slightly feel that. So we'll see what the rest looks like, and we'll take a really close look at that crank pin. Got to plug this in there, LDP camshaft tool. It's our installer handle. I'll get this all the way cleaned off, but camshaft so far looks great. We'll do a full inspection of that, but looks good. Well, here we are. The block is tore down. Got the crank out, cam is out, tappets all look good. Now this block only had cam bearing front and rear. Cam bearings look fine. It will be getting line bored and getting all 7 cam bearings put in it, but they look good. We'll measure the block beforehand just to see if there was any wear in the block. As far as main bearings, the upper half matches the cap side. Number 4 looks as bad, if not worse, than the cap. And what I don't like seeing, the bearing is not tight in the housing. So number 4 was definitely seeing some heat and would have been a problem really soon. So the crank will be sent to the crank shop and checked out. My suspicion is that crank is bent. If it's not bent, it was flexing. But we'll get to the bottom of this and we'll show you what we find. All right, 0.6 ounce inch or 7.8 grams. That is on the front of the crankshaft, and the rear is 0.85. That's about half of our tolerance when we're doing a performance balance job. That's excellent. When I built this, the front was 0.16 and the rear was 0.6 something. So there's a slight change, but this hasn't really been cleaned the best. There's a little bit of rust on the rear face here. So, I mean, you're talking very minimal. So the crankshaft, nothing's twisted. We don't have to worry about any major integral damage or anything. The crank will still be magnafluxed. And we're gonna go ahead and check it for straightness here, and then it'll go to the crank shop. So we're gonna check it for straightness next. Okay, so we're checking the crank to see if it's bent. So we've got it in the stanchions on our balancer here. Normally we would use V-blocks or even put it in the lathe, but since it was on the balancer, I wanted to check it quick myself before it went to the crank shop. So we've got a dial indicator mounted on number 4 main, right dead center of the crank, and the dial indicator has a pretty good stretch here, so it's not the most accurate, but it serves a purpose. So I'll go ahead and turn this and show you what we got going on. All right, so we're zeroed, and I've already checked this, so that's our low spot. So we're zeroed. Okay, so 3 thousandths, but now we're gonna come back, see if it goes back to 0 or not. Half. So if you're seeing it only went back to half a thou, not fully back to 0. And again, 3 thousandths is the max. Back to a half. So 2.5 to 3 thousandths. So the crank is bent a little bit. Okay, so now I'm checking the rods out. This engine, Waggler, Street Fighter, forged rods, and Interstate McBee wrist pins, DLC coated. You can see the coating, no wear whatsoever. Measured with the mic, not even 1/10 of a thousandths of wear. So no wear. Not only the wrist pin bushings the wrist pins hold up good, no wear. So the coating did its job. The coating also did its job on the wrist pin bushings. These wrist pin bushings looked great. When I pulled it apart, you could feel, they felt nice. Really no visible wear, but blown away when I measured them. So I mic'd all my wrist pins and zeroed the dial bore gauge to the wrist pin. So I'm gonna get in here, checking in line with our load where we'd expect to see our wear, and we've got 2.1, so that's 2 thousandths and 1/10. Now we're gonna go sideways. So we got 2 thousandths. I measured another spot and I had 1.9. So 1 to 2/10 of a thousandths of wear. That's it. That is unbelievable. Last year we dynoed several engines at the same power as this, 25 dyno pulls, and we had 2 to 3 thousandths wear on the wrist pin bushings on a different brand of rods. So great quality wrist pin bushing. That's awesome. A couple tenths of a thousandths wear. That's great. On the big end, same thing. Very happy with the big end. So checking the big end. Let's see here, we're about between 4 and 5 tenths of a thousandths over the minimum. So we're right dead smack in the middle of the tolerance on the big end. I'm going to turn it. I check it multiple ways, checking to see if it's deformed or out of round, and you see that within a half a tenth easily. And then we'll go this way. And we're about 2/10 small that way. So overall 2/10. That's killer. This thing, again, 90 pulls between dyno and track. Oil only changed 4 times in that duration. Cracked head with water in the oil. Then that's killer. That's unbelievable. So great set of rods here. We don't have to do anything. No maintenance to these whatsoever to reuse them. Everyone checked out that good too. I didn't have any more than 2/10 wear on any of the wrist pin bushings. And oh yeah, so 2/10, so that's all we lost on our clearance. That's unbelievable. So DLC coating 100% works and very beneficial. Wagler Street Fighter rods, great product. So looking at the cylinder block, specifically the cylinder wall finish, we went in, we did not put the torque plate on, would have been more accurate that way, but we went in and checked cylinder bore wear. The max we had was a half a thousandths, but most spots were only 2 to 3 tenths of a thousandths of wear. The cross hatching, the surface finish, still looked pretty good. Pretty pleased with it. There was definitely some scuffing going on, which 90 passes with everything this engine had been through, not surprised. We did throw our profilometer on here and check the surface finish, and it was right in line with where you'd expect it to be. Now this block was honed with our old Sun-In machine, our old manual hone. It was using like an older method where we took it almost to size within about 3 or 4 tenths of a thousandths with a 280 grit diamond stone, and then finished it with a 320. That was older practice, worked good for many years, but since then we have bought our new Rottler CNC honing machine, and now on these engines we're roughing them in up to size with anywhere from an 80 grit to a max of 170 grit diamond stone, and then we go in and plateau with a 600 grit CBN. And the purpose of that, we put a really deep oil groove, which is known as RVK, the valley, and then we finish it off with that 600 grit CBN, which allows us to plateau. Basically, we're cutting the peaks off. We're giving a nice smooth finish for the rings, giving surface area for the rings to ride on and help them seal, but retaining the oil in those deep grooves. So when we go back and build this customer new engine, he'll have that new technology, which is going to equate to even more power and better ring life. As far as pistons, number 2 piston had a failure. That was ultimately the reason we had to tear this engine down. We did a leak down test, and then we pulled the head and seen the piston. So number 2 piston here, the corner of the pocket that we had machined was the weak link. The cylinder temps were crazy high. This engine got to 260 plus degrees. We don't know how hot it got. We just know it got to at least 260. So the piston rings couldn't transfer the heat, through the cylinder walls, and cylinder temps through the roof, and ultimately it led to the melting this piston here. So again, the pocket, the corner of the pocket was the weak link. That's where it started. So not too surprised. Besides that, very happy with the way the pistons held up. We did do Teflon skirt coating on these pistons. This here is number 6. These pistons had 5.5 thousandths piston to wall before coating. And this engine had a fleece coolant bypass. Again, 260 plus degree coolant temp, under load, and this skirt, number 6, hardly anything. Very minor scuffing, which you would expect. at this level of power usage and having water in the oil especially, but it looks unbelievable. So the fleece bypass 100% did its job. This proves its worth right there. 260 plus degree coolant temp and 5.5 thousandths piston wall, and the skirt looks that good. So very pleased with that. Piston rings. So this engine had Interstate McBee piston rings. We sent the second ring down to Total Seal for a gapless conversion. We run fairly conservative end gaps. Obviously it made good power. The piston rings held up good. Really weren't even truthfully fully broke in. So the oil was doing good, the cross hatching was good, and the rings were happy. So on teardown, we did find several failures in the bottom end of this engine. One of them was the crankshaft. That was evident in the wear we seen on the number 4 main bearing, and we showed you in a clip where we checked the crank to see if it was bent. We sent it to the crankshaft shop and verified it was bent 3 thousandths. I think we come up with about 2.5, checking on number 2 and number 5 journals. When they checked it, it come out to 3 thousandths. So crank was bent, which caused number 4 main bearing failure. The bearing was just starting to get loose in the cap and block, so it would have spun and been a big problem before too much longer. The other problem, the biggest issue, was the failure of the girdle. The Beans gridlock girdle failed, causing the worst bearing fret I've ever seen, at least on a built engine. Bearing fret was horrible. The issue we found was the same that we'd seen in the past. The dowels were pulling down near the top of the caps a little bit, causing the washer to make contact with the aluminum only, which caused it to wear down to the aluminum and lose clamp load, which again caused the worst bearing fret we've ever seen. The caps and the block just looked horrible. So I do know Beans redesigned their girdle. Actually, last year they redesigned it due to this issue, and I believe they're working on another redesign. So the problem has been addressed. Okay, in summary, the one big highlight, Simpico oil really did a great job. The rod bearings looked unbelievable. The wrist pin bushings, only 0.2 thousandths wear. And besides the number 4 main bearing caused by a bent crankshaft, main bearings honestly look great, especially when you consider what this engine had been through. Overheated bad enough to crack the cylinder head, water in the oil, not the best maintenance schedule. This thing sat for an entire off season, fired up and pulled twice with water and oil. So Simpico oil always, does a good job, never let us down, proved its worth once again. As far as the cylinder head, the head cracked, but that was caused by extreme overheat. So it really, really killed me to see that thing go in the scrap bin. I really like that cylinder head. That was a head from Hamilton. Had some extra work done, so it's a shame, but it was way beyond repair. So it's sad to see it go. So the one big highlight, low light I guess you'd say, was the bearing fret. The failure of the girdle and the bearing fret, very disappointed in that. This block is ruined. We cannot use this block. Caps are junk. The block, the receiver grooves where the caps sit are ruined. We'd have to go in and mill about 10 thousandths off. Not worth it. So block was ruined. And as I said earlier, Beans has redesigned. So, this is why we push all of our competition customers to go to 14 millimeter, if not 9/16 main studs. A lot of times we go to billet steel cap. So this is why 12 millimeters, can have a hard time keeping that clamp load, period. But again, this was a failure of the girdle. So as far as connecting rods go, Wagler Street Fighters tickled pink with the overall performance of them. Rod bearings stayed in check. There was no signs of fretting, no signs of caps moving. The wrist pin bushings, Wagler's been, it's been said that they use a very good wrist pin bushing, and it shows 0.2 thousandths of wear. So very happy with them. So A+ there for the Street Fighters. So as the engine builder, overall, I was very happy with this engine. The performance was great. The longevity, everything that was under our control was very good. We were really happy with everything. You know, the engine was overheated. That was out of our control. That led to the piston failure, the cylinder head cracking. Honestly, hindsight 2020 was probably a good thing that that happened though, because otherwise we never would have caught the bearing fret or that bent crankshaft before it spun a bearing. It was too late. So that was a good thing. So, you know, as I said, this block is junk, so we're going to build our customer a whole new engine and get him back on the track. Hopefully we have another good season in 2023, and we'll catch y'all later. So if you like this video and want to see more stuff like it, make sure you subscribe to our YouTube, like our social media, and keep an eye. Thanks.